What if I told you that some of the strangest, most ancient creatures to ever roam Earth are still here, right now, hiding in plain sight? Their bodies carry the blueprint of a world long vanished, yet they have outlived cataclysm after cataclysm. These are the survivors, the living fossils. Chapter 1. The Paradox of Living Fossils. Imagine walking through a forest, the air heavy with the smell of damp earth and moss. You hear a rustle in the undergrowth. Something moves slowly between the ferns. At first glance it looks like an ordinary animal, perhaps a fish, a lizard, or a crab you've seen before. But in truth, what you're looking at has barely changed in hundreds of millions of years. It has seen continents drift apart, oceans open and close, and the rise and fall of entire kingdoms of creatures. And yet here it is, alive in your lifetime. This is the paradox of the living fossil. The term living fossil is a bit poetic. Scientists use it to describe species that look very similar to their ancient ancestors in the fossil record. These creatures have kept the same body shape, the same basic survival strategies, for tens or even hundreds of millions of years. It's not that they haven't evolved at all. They have, but their changes have been so small that they appear frozen in time. Most of us learn in school that life is always changing. Evolution is supposed to push species to adapt, to transform into something new when the environment shifts. And often that's true. But living fossils break that rule in a surprising way. They tell us that sometimes the best way to survive isn't to change quickly to be so perfectly suited to your environment that change becomes unnecessary. Think about it. The Earth has been through 5 mass extinctions. We're talking about asteroid impacts, volcanic winters, ice ages, and climate swings, so severe that most life vanished. Dinosaurs, mammoths, giant sea reptiles, they all disappeared. But living fossils, they endured. They found a way to outlast the chaos. Part of their success comes from stability. Many living fossils live in environments that have stayed relatively unchanged for millions of years. Deep ocean trenches, remote islands, and ancient river systems act like time capsules. They shield these creatures from the dramatic changes that happen elsewhere. For example, a fish living hundreds of meters beneath the ocean's surface doesn't have to worry much about seasonal temperature swings or predators from above. Life down there moves slowly, and so does evolution. Another part comes from design. These species have body structures and behaviors that work so well, they haven't needed much improvement. Imagine a key that perfectly fits a lock. There's no reason to file it down or reshape it if it opens the door every time. In the same way, the body plan of a horseshoe crab or the lobed fins of a coelacanth have served them well for ages. But there's also a more mysterious element, a kind of resilience we don't fully understand. Why is it that some species vanish almost instantly when the climate changes, while others endure it like nothing happened? It's one of the big questions in evolutionary biology. Maybe it's a matter of luck. Maybe it's about having the right combination of traits at the right time. Or maybe there's something in their biology we haven't discovered yet. Take the coelacanth, for example, a creature that will get its own chapter in this story. Scientists thought it had been extinct for 66 million years. Then, in 1938, a fisherman pulled one up off the coast of South Africa. It was as if someone had plucked a ghost out of prehistory and dropped it into the modern world. That moment shook the scientific community because it proved we don't know everything about our planet. It also reminded us that the line between past and present isn't as sharp as we think, and the coelacanth isn't alone. There's the tuatara from New Zealand, a reptile that looks like a lizard, but comes from a lineage older than snakes. There's the nautilus, with its beautiful spiral shell, still floating in the ocean just as it did before the age of dinosaurs. And then there's the horseshoe crab, walking the same beaches it walked 450 million years ago. These creatures are like windows into deep time. They let us glimpse what the Earth was like long before humans existed. But they also survivors in the present, living proof that life can endure for unimaginable stretches of time. When you see one, you're not just looking at an animal. You're re-looking at a design that has passed nature's harshest tests over and over again. There's something humbling about that. We live in a world obsessed with speed, fast technology, fast growth, fast change, Living fossils remind us that slow, steady, and unchanging can be a winning strategy. They've watched meteors fall, continents shift, and oceans rise and fall. They've been here longer than the mountains in some parts of the world, and unless we destroy their habitats, they may outlast us, too. But make no mistake, their survival doesn't mean they're invincible. Many living fossils are in danger today because of human activity. Overfishing, pollution, and climate change are erasing the environments that have kept them safe for so long. Some species that survived the extinction of the dinosaurs might not survive the century. That's part of the urgency in studying them. They are both relics of the past and fragile treasures of the present. In this series, we'll step into their world. We'll explore the dark depths where the coelacanth swims, the wind-swept islands where tuatara bask, and the moonlit beaches where horseshoe crabs gather. We'll see how their bodies work, how they feed, how they reproduce, and how they've managed to resist the tide of change for so long. By the end, I hope you'll see them not just as strange animals, but as symbols of survival. They're living reminders that life finds a way, sometimes by moving forward, and sometimes by standing perfectly still. Now, let us begin with the most famous living fossil of them all, a fish that rose from the pages of prehistory to swim again in our modern oceans. Chapter 2. Coelacanth, the ghost fish from the Devonian. If you had lived just 100 years ago and asked any scientist about the coelacanth, they would have told you with complete confidence, it's gone, extinct, lost to history for 66 million years, just like the dinosaurs. Its story was supposed to be overburied in ancient seabeds, preserved only in stone. And then, one summer day in 1938, everything changed. Off the coast of South Africa, a fisherman hauled up his net and found something strange thrashing among the catch. It wasn't like any fish he had ever seen. Its scales shimmered with a metallic blue-green sheen. Its fins were thick, almost like limbs, moving in a slow, deliberate rhythm. It had eyes that seemed to look right through you, ancient, almost unbothered by the fact that it had just been dragged from the deep. That fish turned out to be a coelacanth, alive and breathing, a creature thought to have vanished millions of years before humans even existed. The shock in the scientific world was immediate. Imagine believing you have the complete picture of history, only to discover that one of the most important pieces has been quietly swimming beneath your feet the whole time. The coelacanth became more than a fish. It became a living reminder that we don't know our oceans as well as we think. The coelacanth story begins around 400 million years ago, during the Devonian period, often called the Age of Fishes. Back then, the seas teemed with bizarre and powerful creatures. The coelacanth's ancestors swam alongside giant armored fish, primitive sharks, and early forms of plants that were just beginning to creep onto land. These fish were already special, with a body design unlike almost anything else in the ocean. Its most distinctive feature is its lobed fins. Unlike the thin, fan-like fins of most fish, the coelacanth's fins have a thick, muscular base with bones inside bones arranged in a pattern that looks eerily similar to the limbs of amphibians, reptiles, and mammals. This has led scientists to believe that the coelacanth's relatives may have been part of the evolutionary branch that gave rise to land-dwelling animals. In other words, the shape of its fins might be an echo of the moment when life first stepped from water to land. But the coelacanth didn't follow its relatives onto the shore. Instead, it chose the deep, retreated into dark underwater caves, hundreds of meters below the surface, where sunlight barely reaches. In these hidden refuges, it found stability. The water there is cold, oxygen poor, and remarkably consistent year after year. While the surface world was thrown into chaos by shifting continents, asteroid impacts, and ice ages, the coelacanth's home remained almost the same. That's one of the keys to its survival, living in a place where time moves slowly. The coelacanth has other strange features that seem to belong to another era. It has a hinged joint in the middle of its skull, allowing it to open its mouth extra wide to swallow prey. Its scales are thick and armored, more like plates of ancient armor than the flexible scales of modern fish. Its heart is shaped differently from most vertebrates, and it gives birth to live young after carrying them for more than a year, a remarkably long gestation for a fish. It's also slow, very slow. Coelacanths don't chase their prey with bursts of speed like tuna or sharks. Instead, they hover in place, drifting with the currents, conserving energy. When they move, they do so with a graceful, almost hypnotic rhythm, their lobed fins rotating like the arms of a clock. Watching one swim is like watching a ghost, silent, deliberate, unhurried. In the deep sea, patience is a form of power. For decades after that first 1938 discovery, sightings of coelacanths were rare. Scientists and fishermen alike were unsure if they would ever see another. Then, in the 1950s, another population was found near the Comoros Islands, and later, a second species was discovered off the coast of Indonesia in 1997. These discoveries proved that coelacanths were not a single relic clinging to survival. They were a small but resilient group, quietly living in scattered pockets of the Indian Ocean. Today, we know a bit more about their habits, though much of their life remains a mystery. They prefer steep volcanic slopes and caves, where they rest during the day and hunt at night. Their diet is made up of squid, small fish, and other deep-sea creatures. They are not aggressive, and because of their slow metabolism, they can go long periods without eating. But their vulnerable deep-sea fishing and habitat disruption have put them at risk. International protections now aim to safeguard their numbers, but their population is still small, likely only a few thousand individuals. The coelacanths' rediscovery was more than a scientific surprise, it was a philosophical reminder. If something so large, so unique, and so ancient could escape our notice for decades, what else might be out there? Our oceans cover more than 70% of the planet, and we've explored only a fraction of them. Somewhere in those depths, there could be other survivors from the ancient world, waiting to be found. The coelacanth proves that extinction isn't always the end. Sometimes, life finds a way to hide, to endure, and to wait for the right moment to reveal itself again. When you look at a coelacanth, you read not just looking at a fish, you re-looking at a survivor of the same ancient seas that gave birth to the first forests, the first winged insects, and the first creatures to breathe air. You re-looking at a design so perfectly suited to its environment that it has remained nearly unchanged for hundreds of millions of years. In a world where everything seems to move faster every day, the coelacanth is a living testament to the power of staying the same. And maybe that's why people find it so haunting. It's not just that it came back from the dead, so to speak, it's that it never left. It was always there, gliding through the shadows, carrying the memory of a world we'll never see. Next, we'll leave the deep sea behind and travel to the windswept islands of New Zealand. There, another living fossil has been guarding its ancient secrets for over 200 million years. A reptile with a third eye and a slow, deliberate heartbeat. Meet the tuatara, the reptile that time forgot. Chapter 3: Tuatara, the reptile that time forgot. If you were to see a tuatara for the first time, you might think you're just looking at an ordinary lizard. The scales, the slender body, the slow, deliberate way it moves, it all fits the picture of a reptile you might find sunning itself on a rock. But the tuatara is not a lizard. In fact, it isn't closely related to lizards or snakes at all. It comes from an ancient lineage that split from theirs over 200 million years ago, back when the supercontinent Pangaea still held most of Earth's land together, and dinosaurs had only just begun to rise. The tuatara is the last surviving member of a once mighty order of reptiles called Rhynchocephalia, a group that flourished across the globe during the age of the dinosaurs. All of its relatives are gone now, their bones locked in stone, their names known only to paleontologists. Yet somehow, against all odds, this one species endured. One of the tuatara's most remarkable features is something you can see immediately: its third eye. This parietal eye sits atop its head, under a thin layer of skin. It doesn't see images like its other eyes do, but it can detect light and dark, helping the animal regulate its biological rhythms and perhaps sense changes in the sky above. When tuatara hatchlings are young, this eye is more visible, a small pale spot on the head. As they age, scales cover it, hiding it from view, but it never disappears. It's a living reminder of ancient sensory systems that most other vertebrates have lost. Then there's its metabolism, astonishingly slow. The tuatara grows so gradually that it can take more than 30 years to reach full maturity. It can survive in temperatures far colder than most reptiles could tolerate, and it often goes for long stretches without eating. This slow pace of life is part of why tuatara can live so long. Many surpass a century in age, and there are records of individuals reaching 110 or even 120 years. Imagine a reptile born before the first manned flight at Kitty Hawk, still alive to see spacecraft land on the moon. Their origins are so ancient that tuatara once shared the earth with early dinosaurs, mammal-like reptiles, and the first small mammals. Through mass extinctions, ice ages, and continental shifts, they've held on to a design that simply works. Their skeleton muscles and even their teeth fuse directly to the jawbone, almost identical to fossils hundreds of millions of years old. It's as if time has moved forward, but the tuatara has stayed behind, perfectly preserved in a living body. Yet for all its resilience, the tuatara survival today hangs by a thread. They are found only in New Zealand, and even there, not on the main islands. Instead, they live on a scattering of remote offshore islets, places too rugged and isolated for human settlement. The reason is tragic. When humans arrived in New Zealand centuries ago, they brought with them rats, cats, dogs, and other predators that quickly wiped out tuatara from most of their range. On the mainland, they simply could not compete or defend themselves. Their eggs, which take an extraordinary 12 to 15 months to hatch, became easy prey. Their slow reproduction rate couldn't keep up with the losses. For decades, scientists feared the tuatara might vanish entirely, but New Zealand responded with a bold conservation effort. Populations were protected on predator-free islands, and in some cases, tuatara were reintroduced to secure habitats after careful eradication of invasive species. These programs worked, and today, their numbers are slowly recovering. Still, they remain vulnerable. Just one environmental disaster or predator incursion could devastate an entire population. The mystery that continues to fascinate biologists is how the tuatara's biology has stayed so unchanged over such an immense span of time. Evolution is constant for all living things, yet the tuatara's core anatomy and physiology seem frozen, echoing a body plan perfected long before humans ever walked the earth. Does this mean that tuatara has stopped evolving? Not exactly. Genetic studies show they are still adapting in subtle ways, but the blueprint has remained stable, because it is so well suited to their environment. Watching a tuatara bask in the dim light of dawn, you realize you are in the presence of something truly ancient. This isn't just an animal, it's a messenger from another world. One that existed before flowers bloomed, before birds sang, before mammals dominated the land. Its very existence bends your sense of time, collapsing the gulf between our modern Earth and a lost age when reptiles ruled. And in those quiet moments, when the tuatara's unblinking eyes meet yours, you can't help but feel that you are looking into the deep, enduring memory of life itself. Chapter 4. Horseshoe Crab, Blood of the Ancients. If you were to walk along a quiet beach on the eastern coast of North America during a warm spring night, you might see something strange moving in the moonlight. At first, they look like little armored tanks, crawling slowly out of the shallow water. They have hard, rounded shells shaped like shields from an ancient battle, long spiny tails dragging behind them, and many small legs hidden underneath. These are horseshoe crabs, creatures that have walked the earth for over 450 million years. That is more than twice as long as the dinosaurs existed. They were here before trees covered the land, before birds filled the skies, and before the continents took their modern shapes. In a way, looking at a horseshoe crab is like looking through a window into deep time. The body of a horseshoe crab is unlike most animals we see today. It is divided into three main parts: the broad dome-like shell that protects its main organs, the spiny tail, called a telson, which helps it flip over if waves push it upside down, and a lower section with many small legs and book gills, which let it breathe underwater, but also survive for short times on land. Its eyes are another marvel. Horseshoe crabs have not one or two, but up to 10 eyes scattered across their shell and tail. Many of them compound eyes like those of insects. These eyes are so sensitive to light that scientists have used them to understand human vision. Yet, for all their strange features, they move with a slow, deliberate grace, as if time itself has little hold over them. Perhaps the most mysterious part of the horseshoe crab is its blood. Unlike human blood, which turns red because of iron in hemoglobin, the blood of a horseshoe crab is bright blue. This color comes from a copper-based molecule called hemocyanin, which carries oxygen in their bodies. But this is not the only remarkable thing about it. Horseshoe crab blood contains a special substance called limulus amoebocyte lysate, or LOL, which clots instantly when it comes into contact with harmful bacterial toxins. This ability is so sensitive that it is now used in modern medicine to test every vaccine, every IV drip, and every surgical implant for contamination. Without this test, countless medical treatments would be far more dangerous. In other words, the survival of these ancient animals has directly helped us protect human lives today. But horseshoe crabs are not just medical marvels. They are also survivors of incredible global change. They have lived through ice ages, asteroid impacts, and mass extinctions that wiped out most other species. Part of their success lies in their adaptability. They thrive in shallow coastal waters, where they bury themselves in the sand to avoid predators, and they can eat almost anything: worms, clams, and even algae. They are patient and slow-growing, taking up to 10 years to reach maturity, and they shed their shells many times as they grow, leaving ghostly remains on the shore. Their most famous behavior, however, is their ancient spawning ritual. Every year, during the high tides of the full and new moons in spring and early summer, hundreds of thousands of horseshoe crabs crawl ashore together. The females dig shallow nests in the sand and lay thousands of tiny green eggs. The males cling to their backs, fertilizing the eggs as they are laid. Under the pale silver light of the moon, the beach comes alive with the quiet, steady movement of armored shells. It is a scene that has played out for hundreds of millions of years, unchanged even as the world around them transformed again and again. Watching them, you realize you are witnessing one of the oldest surviving rituals on the planet, older than the first flowers, older than the first birds, older than the very continents we stand on. Of course, even the oldest survivors face threats in the modern world. Horseshoe crabs are collected for their blood in medical testing, though in many places they are released afterward. They are also harvested as bait for certain fisheries, and their eggs are an important food source for migrating shorebirds. Coastal development and climate change are reducing the beaches where they spawn. Conservationists now work to protect them, knowing that their loss would not only erase a piece of Earth's ancient history, but also remove a silent guardian of human health. And yet, there is a certain resilience in them. Year after year, they still appear under the moon, their shells glistening wet as they haul themselves from the water. They seem untouched by the rush of human time, as if they know that survival is not about speed, but endurance. In the stillness of that moment, with the waves lapping at the shore and the stars above, you can almost feel the weight of deep time pressing gently around you. The horseshoe crab does not hurry. It has already outlived the dinosaurs, the mammoths, and countless other creatures. It will continue its slow, patient journey for as long as the tides allow. When you watch them crawl ashore under a full moon, you are not just seeing animals, you are witnessing a living memory of Earth's distant past. They are reminders that some designs are so perfectly suited to life that they never need to change. And maybe, in that quiet persistence, there is a lesson for us too. Chapter 5. The lesson of survival. When we step back from each of these ancient survivors, the coelacanth lurking in deep ocean, shadows the tuatara basking quietly on rocky islands, the slow and steady horseshoe crab navigating the tides, we begin to see a pattern that is both humbling and thought-provoking. Their existence is not simply about enduring for millions of years. It is about mastering a balance between adaptation and stability. For most of us, when we think of survival, we imagine rapid evolution, constant change, and the ability to quickly adapt to a shifting world. But these species tell a different story, one where success sometimes means holding on to what already works, refining it subtly over eons, and resisting unnecessary change. The coelacanth has survived extinction events that wiped out entire lineages. It has outlasted the dinosaurs, the great marine reptiles, even the shifting of continents. It did this not by becoming something entirely new, but by existing in a niche so specific and stable that it had no need to reinvent itself. In a way, the coelacanth is a master of patience, sir, a living symbol that you, Dan-T, always have to keep pace with the rest of the world to endure. The tuatara is similar. It has watched countless other reptilian lines rise, diversify, and vanish, yet it remains almost exactly as it was over 200 million years ago. It has done so by thriving in isolated pockets of the world, away from the pressures that push species into rapid change. Its biology is like a preserved time capsule, offering scientists a glimpse into an age before snakes and lizards, and challenging our understanding of evolutionary speed. And then there is the horseshoe crabber creature, whose story stretches back nearly 500 million years. Its survival is a testament to resilience in the face of unimaginable planetary upheaval. From ancient shallow seas to today's bustling coastlines, it has followed the same moonlit rituals, crawling ashore in massive gatherings that look like something out of prehistory. And in a strange twist, its blood blue and copper basties, now essential to modern medicine, making it one of the few ancient creatures whose survival benefits our own. Together, these animals remind us that the idea of progress in nature is not always a straight line. Evolution is not a race to become the most complex, the fastest, or the smartest. Sometimes, it is about finding a way of life that works so well. It needs only the slightest adjustments over immense spans of time. These living fossils are not failures of evolution. They are masterpieces of its designs, so perfectly tuned to their environments that change would be unnecessary, even risky. There is also a deeper philosophical layer here, one that reaches beyond biology and into our own lives. We live in a world that is obsessed with constant growth, with reinvention, with the pressure to always be moving forward. But maybe survival is just as much about knowing when to stay the same, to protect what works, to resist unnecessary change, even when the world demands it. These species have endured asteroid impacts, ice ages, the rise and fall of continents. They have persisted through the collapse of ecosystems, the birth of new predators, and the shifting chemistry of the oceans. And through it all, they have held on to their identity. They are living bridges between the distant past and the present, proof that life can endure unimaginable upheavals without losing its essence. They tell us that sometimes the best path through the chaos is not to constantly reinvent yourself, but to double down on what makes you strong in the first place. And perhaps most fascinating of all, there are likely more of these ancient survivors out there, hidden in the unexplored corners of Earth. The deep oceans, the dense rainforests, and the remote islands may still hold species whose lineage stretches back to the dawn of life itself. If these three remarkable examples have shown us anything, it is that we have only begun to scratch the surface of our planet's true history. Every one of these animals is a living reminder that the story of life is not just about the future, it is also about the immense, unbroken thread that ties us to the past. They are survivors not only of time, but of every cataclysm time has carried with it, and that is why they fascinate us. If these ancient survivors fascinated you, imagine what else is still out there, waiting to be discovered. Share your thoughts in the comments. Tell me which living fossil amazed you the most. And if you want more journeys into Earth's hidden past, don't forget to like, subscribe, and join me for the next story. Because somewhere, in a forgotten corner of the planet, another ancient heartbeat is still echoing through time, and one day, we might just find it.